I have the honor of speaking after Tim, which usually is bad because the quality of Tim's presentations is mostly better than what you can expect from me. So it will be worse from here. The other thing is I'm usually good at making even worse slides, so don't expect that much. What I want to talk about, like it's already mentioned here, Gecko.io. Gecko.io is kind of our version of en route, which you will see many things that are quite close to what Tim has shown you, just using, in this case, Gradle as the base for building this. Most likely BJ and Tim will beat us with it afterwards because all of the bullshit I'm telling you here. But I hope that we can get some more close cooperation. But before I start, some words to me and my company. My name is Jürgen Albert. I'm the founder of Data in Motion, founded in 2010. We basically work since the beginning with OSGi in some way or another. Started out with RCP applications and then moved to the server side from there. And we talked to the guys from the OSGi Alliance for quite some time at the OSGi community event and the Eclipse Con, and finally decided to join 2 years ago, I believe. Or yeah, this year it will become 2 years ago. 2 years that we are here, and because OSGi is one of our biggest focuses, and yeah, we're officially the smallest member of the OSGi Alliance, so next to other big companies, but here for everybody who's using it and likes to become involved, just do it. It's a volunteer army, so everybody is doing it for the fun of it, nobody because he has to do it. And the reason why I have this slide is we are hiring, so if somebody wants to work with model-driven software development in OSGi, I should not tell this loud, I guess, here. Not that Indosha beats me afterwards. So, yeah, what have we done? What is Gecko.io? Gecko.io is basically what we started out doing what we have been doing all the time. We build our modules, we build our separate features which evolved around all this modeling stuff. We use EMF a lot, and we try to need some kind of space where we could put it. So at the beginning we had some kind of simply data in motion open source, and then we decided, okay, we can try to pack it in a real open source project. So, and this was what Gecko.io became. The name is because we already had a logo. So we had formerly a company called Geckoware, so there's a logo from, and yeah, so it started out as an incubator for our projects, which we share between our customers. So usually what we do for one customer, we can reuse thanks to OSGi and bundles and well-defined APIs at other companies and other customers. 2 years ago, as we started with the Alliance, we switched from using the old PDE build, no idea if who has heard about it, to using BND, and we realized how easy it can get. So all the stuff you had seen from Tim that happened there in the recent years, we started adopting ourselves, and we often create new projects. So because we have many small projects like Docker containers and so on and so forth, and we wanted to make our own life easier. So we started creating our own workspace templates, our own project templates, and so on and so forth. And so we decided to share this, so to give everybody the ability to get started like with en route, just with our stuff here. And furthermore, we started building our own implementation of certain specifications. For example, the JAX RS whiteboard you have seen, Tim showed off with the CXF implementation, which is the reference implementation. We have an own implementation using Jersey underneath it, and this is something which is placed there. I will show you later. Yeah, and the other purpose we had was to enable all our modeling stuff all around EMF in a pure OSGi environment, because due to the fact it basically is OSGi and it works in Eclipse, which is based on OSGi and is used a lot, but we had to tweak it a little bit because they use many of the things which are not really standard compliant for OSGi. They use some legacy Eclipse stuff, which makes it bad interacting with other OSGi implementations of the framework. So this is what we did there, and then it went on and on. So the templates I've already talked about. So we created some more tooling for code generation and so on and so forth. So this is basically how we got with what Gecko.io is, roughly. I will show in the detail later. So the thing is, yeah, it is just our fun project. No, it's actually people out there using it. So we use it everywhere on the embedded side, servers, microservices, you name it. You can use it for everything because it's basically pure OSGi what we are doing there. The other thing I'm proud to say, I hope I can say it, I'm allowed to do it. The city of Vienna, the Kommunalservice, is using it as well in parts. And our other main customers, for example, like Radio.net or Swaco Traffic Systems, they are building traffic stuff like traffic lights, lightning, signs for the traffic area, parking lots, and so on and so forth. And at the moment, we're in a pretty, at the starting stage, so most of the things are published. So at the moment, it's just a GitLab where everything is lying around, plus our repositories. So what we want in the future is at least a website. So that's something to that we have something to show for. A little bit more of documentation and tutorials. And maybe if somebody else likes to needs some space to host its open source OSGi implementation or modules or whatever, to give people a space to host it, we have a Hudson we can provide, we have a Nexus we can provide, and so on and so forth. And also like I said, BJ and Tim, I guess they will see it for the first time. So we're looking forward to see how good this can be incorporated in Eclipse en route. So maybe we can push stuff there. From the stuff we are doing, but we have to look how it works. So what do we have on OSGi specifications? Like I already said, the JAX RS whiteboard implementation based on Jersey, because not everybody likes the CXF implementation, so there's another one. We are not 100% spec compliant at the moment. I have to check what's open for the rest of the implementation. So. But it's usable, it's in productive use, productively used by customers of us. So there are some minor things like DTOs or some things that are missing, but not that much at the moment. The other thing, which is also in alpha version, is the remote service admin. All the services you had seen with Tim's example, you can with OSGi easily make a remote service, so you only have the API bundle in your system and the actual implementation is somewhere else, and you don't have to care, you don't have to write an API by implementing the REST interface and so on and so forth. So the remote service admin takes care of this for you. Hopefully an upcoming spec for the next version of OSGi, the message adapter Mark is working on, which can give you unified access to all kind of messaging systems from CAN bus, MQTT, JMS, WebSockets, whatever you want to use. This is where the one API and different implementations comes in handy. So you have one front and you don't care what it's underneath it. So if the MQTT is not available anymore, then you take the AMQP version whatsoever. So all our modeling stuff evolving around EMF. So EMF itself, we just put a wrapper around it to make it really dynamic, so you can dynamically add your models and all this functionality EMF entails. All the add-ons like QVT, I will show you later. It's like a transformation language for your models. So if something comes in from the API, you can transform it easily to the stuff in the backend, which lands in the database. You can compare your objects and get a real diff, and they say, okay, your first name has changed or this has changed, and on your models before you save them, so you can react to it. We also have a persistence layer for MongoDB with EMF, which is quite fast, and we call the EMF repository, which is basically only easy access to the persistence underneath, which can be Mongo or file at the moment. But there are other implementations out which can be used. And then the tooling, because this is why I said it's also we have some professional view on all this stuff, because if you are in a bigger company, you have often that you have to new people in the team, so people have to get started easily and quickly. So usually everybody knows you are on the onboarding phase in a new company. You have a list like this, what you have to do, where you can get your accounts. This is where you have to install your IDE. These are the plugins that have to be used, and so on and so forth. And so we started out with an Eclipse installer, which uses the OAMP. Maybe somebody has heard about it, which presets and say, okay, yeah, we want BND installed, we want the modeling stuff installed, we want the editors installed. and so on and so forth. I will show you the workspace templates and the project templates. They are quite similar to the archetypes Tim has shown you, and also some special exporter for the product in the end with a Docker build included, and yeah, code generator for the EMF stuff. So and some other things to enable EMF also for your API, and some security, and also support for different serialization methods also for the objects. So this is yeah, quite right. That is just an idea what we do there. Best thing is to show it live. So I will redo basically what Tim did, just with the Gradle version of it. And so this is what we do on a regular basis. I hope this is somehow visible. So here we have our Eclipse. Everything is enlarged as usual. So this is how we start on a blank page. This was installed with our installer, so you can get the OM set up on our in one of our projects as well. So everybody can do it too. In this case, we simply start by saying, okay, we want a new BND OSGi workspace. So this is another way of creating your starting point. Tim already mentioned that BND itself, BND tools, comes with prepared workspaces. This is, for example, the default workspace, which we took as a base and built upon. And in this case, we have here our Gecko.io workspace, which comes around and creates some people might know it. You see there are a lot of files that are coming with it. So which gives you a basic setup of the workspace with a couple of repositories that should be pop up here. So where you can get the Eclipse stuff, some stuff from Maven, everything you need to use all our Gecko stuff. So you're ready to run and roll. We included kind of release mechanism. So when you have a CI build on your Jenkins or stuff like this, you can say, okay, I want to do a snapshot build or a release build, which then has different ways of building this stuff. By default, you don't see it here. We come along with README contributing in the GitLab CI, the Travis CI I've never tried. This is the one that BND workspace itself is bringing with it, so it would automatically build on GitLab or GitHub, whatever you want here. So this is the basic setup we provide with everything we think that is needed or which we are using most of the time. So and then we can start it from here and say, okay, now I will do the same thing as Tim did. We start with something, okay, we want to, we need some kind of a runtime. So we need a nucleus where our service starts, where our server starts, or even better, our application, where we have configured our database connection and so on and so forth. And therefore, we have our Gecko templates here as well. So in this case, we take the Gecko server runtime as a project template. We just call it test.runtime. Next thing, it will ask us, okay, how should the Docker image be named, which can be built here if you'd like so. So we say this is the image and the group. And here we go. So it creates for us a project, which in and of itself is not that much to look at. It provides us with a run configuration, like you have seen with Tim's example. This is what you can start. This is what you can export in the end, where you get your runnable out of it. A build Gradle, which is doing the modified build for the Docker stuff. So when you would like to build Docker. And also we, like I said, we have our own exporter, which is doing a little bit more than the normal self-executable jar. I will show you in a minute. And together with this, we have, you've had asked how configurations can come to your service. Everything in OSGi basically is a service. So your database connection is configured as a service. Your server itself is configured as a service. So this is what we are doing here. We have the configurator spec, meaning that you can put, in this case it's JSON format, configurations in it, which then say, okay, I have a component which is named JAX RS whiteboard component, for example, which is the whiteboard. It should run on 8080. This is the whiteboard name, and this is the context path it runs under. Same thing with the Mongo database. This is, in this case, our EMF Mongo database, which is configured here, also with properties. We have a Docker run, Docker compose inside it, which in this case is as a version for where just the MongoDB is available, or for the local development, or on the other hand, which you can use to start your infrastructure where the image and the, this was the name I've given, is set up. So after the build, you can just, as you're ready to roll basically for the first things. So what we can do on the other side, just to have a small look at the, how do I call it, test runtime, and I can do Gradle, Gradle v build Docker, and this should trigger the build at some point. I hope it is roughly readable. Gradle is doing its Gradle stuff, downloading the internet. And the first time it fails from time to time. It's hard to debug because it's on the first time. When I do it again, it works. So maybe BJ, if you have an idea why he can complain about JUnit. So it's only on the first run. So here we are. It prepares the Docker build, and we will see in a second how it's building Docker. And we are ready to go. So, and it did a little bit more for us. So usually, many people, as we have been starting with BND, it was like we had the problem of, okay, how do we get all this stuff now running? How can we get our assembled product in the end? So this is what we, BND has a nice exporter which can give you a self-executable jar, and also a deflated version. We have some little bit more structure around it. And this is what we build upon, because in some cases you want a little bit more. You want a startup script, you want a config file for your, like your memory consumption, you want the data area, workspace area, which is usable in your server. And this is what we generate here as well. With here, this is where the Docker build happened. And in this case, we have this zip, which contains, on the one hand, a configuration file with all the stuff you need to enable. You know it from most of the servers, so Tomcat comes around with something like this. In this case, we used as template the Jboss startup script. So we have a log file area. We have somewhere where you can put, for example, your logback XML, where logs go, and so on and so forth. And if you want to do it by hand, the Docker image, the Docker file, which is used to build all the stuff. And also, if you want to use it as a system daemon, so here are the scripts, you just have to copy on your server and use it. If you want to do it like this. So, and what else do we have? We have a prepared run configuration, which basically at the beginning starts with nothing really except the Gogo shell, a little bit declarative services, so the configurators, the stuff which is basically needed. And something else, an annotation you can put on add to all of your projects, where it says, okay, this is what we require. This is what Tim was talking about. Somehow the resolver needs to know, okay, if I have a service here, which is a JAX RS participant, somehow where he needs to know, okay, I need a JAX RS whiteboard, I need this and this and that. So all these indirect dependencies. And here we have, for example, our stuff. We say, okay, we need a JAX RS whiteboard as well. We will need, in this case, our EMF JSON. So when it's a REST resource, EMF is available and JSON is available, and all our the things we use in the background, and provide. Here you can use your own application domain-specific annotations where you say, here's my business logic, and this is the annotation to require it. So we can go on from here and say we go to the next step, and we want to start the same example as Tim had. We want to do a whiteboard component. So we have a template here as well, which just says, okay, this is our test.rest. And this will create for us a neat little demo resource, which might look familiar to you after what Tim has been showing. And for our case, we do a slight modification from the default template. First of all, we add our dependency to the runtime because of the following reason. I want to say here, okay, add require our runtime. Require runtime, here we are. Say save, and then the same thing you had seen before. In my launch configuration, I say, hey, okay, I want to edit as well. So this view is not updated, and I have to pull it from here. Say save and resolve. Resolving in this case takes a little bit more time because the resolver has to go through a lot of options, and we provide a lot of possibilities he can go through. Not quite sure, maybe the 4.1 version with the new resolver might be quicker or better. No idea, I've never tried it till now.
Yeah, I mean, it depends how complicated your question is, right?
Yeah, that's
it takes to answer it.
That's the thing. So I guess we have to thin out our repositories a little bit because we have all our old versions also in one repository. But here he comes and tells us like, hey, we have XML, the GoGo shell, HTTP, the Jetty, EMF, also everything that was defined by our require capability, our require annotation. And now I say save, and magically we will see, should see, all the stuff gets installed, the Jetty gets pulled up. You can see here the debug stuff from our Jersey implementation, which tells us what's attached to our current whiteboard. And surprise, surprise, here we are with Hello World with a small h in here. So you see, this is basically another approach to work with OSGi and with BND. So I haven't looked at the time, so it's just a couple of minutes to have a server set up, have the same functionality as Tim did with Maven. So if you like Gradle more, this could be a possibility to do it. And yeah, this is the one part I'd like to show you, which is basically just, okay, here we get started, here we can do stuff. I've prepared another small example, which is this one here. It's a slightly more complex project. I have to stop this here so they don't get in conflict with each other. In this case, we have a little bit more complex setup. We are in Jena and it's e-commerce, so I have made a little shop project myself, basically looking like the following. We have the runtime is here as I had before with all the stuff looking exactly the same. At the moment I have one REST endpoint which is still named demo. We have the hello stuff in here, and in this case it will return a product for us. So we can say, yeah, this is my ID, this is my language, and the version I will tell you later about where I can get my stuff. In this case we use the product service, which is, as Tim had shown, just an API. In this case, we give a blank E object zurück, which is an EMF object. And okay. And we have two things in the data. Usually you have your API model and you have your database model, because you don't tend to give the objects you have in your database directly as they are in the database out to your customers. So I have two kinds of models. The one thing is the hyped and fancy EMF model, which describes our shop and backend, so which has a product has an ID, a name, a description, and because you have multiple languages you can support, they are a list of translations, which then have the language code and the actual value. So nothing fancy here. And has somebody worked with EMF at some point? Okay, two hands. EMF in the end is generates code for me. The code itself at the beginning does not look that fancy. It simply gives me interfaces for my product, for my stuff. It gives me implementations for it, and basically, and has a lot of more functionality than the usual Pojo. And the good thing is I always have a described model, which I can use to serialize it. I don't need any kind of reflections to work with it if I don't know what I'm seeing there. So I don't need, you can, with this, you can serialize it in different formats, like we use it for the MongoDB. You can use it as JSON, you can use it as XML, binary, YAML, whatsoever. All of this is behind these objects, because whoever wants to serialize it can look at the formally described model behind, which is in the end nothing else than UML. And yeah, on the other hand, we have our API model, which is also not that fancy. It's simply, I called it the API product. It has an ID, a name as a string. It's no translations anymore. This needs to be translated. A language code, which language it is, and a description. In this case, in the specific language. And we have something else here, the transformation rules on how this should be transformed from one thing to another. Here in this case, there's a QVT, it's a standardized language you can use without knowing anything about the programming language underneath. So it does not need, don't need to know anything about Java. You don't need to know anything about JSON or whatever JavaScript, whatever is it's used in afterwards. So, and here, this is simply doing a translation, taking the original product. They have this fancy editor with auto-completion and so on and so forth. He knows about my models, so I can use it to easily write the transformations for this. And I say, okay, go through my language codes, through my translations, look for the German translation, put the value, the description here, and add the language. So nothing fancy here as well, just to give you an idea. And last but not least, the product itself is the product service has an activate method where I create two default products which I put in a database. I require my repository to interact with my database, and something else you had seen before. I have a mandatory transformation factory I need, and also a dynamic list of multiple templates that can be registered with me. So these are the templates I will use later to do the transformation. So this is the same thing Tim has shown. So something comes in, I get my template URI, which is registered as a service. Because by hand, for example, you can register anything as a service. It does not necessarily needs to be done by declarative services with an interface or something. You can register a string, a simple object, whatever. So it's your choice what you do. In this case, we register the URIs to the templates with the properties, and then I edit, create a transformation factory, and so on and so forth. So this is what you easily can do, because the system gives it to you. Whoever registers the URIs in the service registry does not have to know who will use it in the end. It doesn't matter. You don't care about it. Somebody else takes care of it. So in here I then say, give me the object. I want the product with this ID. Get this API, as this shop product out of it, and then I just say, okay, give me the Travo, which is the current version in the language, and then start the transformation and return this product, this object, which is then given through the REST interface. So, and when we run the, where are we? Here. When we run it in the end, This is one of the reasons why we only start usually our launch configs once, and then we leave it running because of the initial starting time. And so here we are, have our demo product with ID 1, and here in this case in English. So here we have it as a JSON. It says, this is an API product. This is the fancy product name in English. It's English language code. I can do it in Germany as well. So nothing fancy here. I can even look at now I have a special version where I just use the object I get from the database and return it. So I can say plain here, which is showing the object as it would be, so as it is in the database. So you always use the same entities. You don't need special entities like with JPA, where you have to your REST entity, and then you have to transform it somehow to your JPA entity or whatever data type you have. So here you can use it wherever you want. It's always the same object, so in the same kind of object. And this gives you a lot of nice possibilities. Then, for example, in also the one thing is I can, which is even not too shop resource. We want it as YAML, then we will get it as YAML.
Nice shop, by the way.
Yeah, great.
And also produce HTML.
Can in the end, but here we
Don't have a truffle for this.
yeah, we would need one of these. Where is it? I have to open it again. So obviously Chrome can't read YAML. Oh, here we have our object as YAML, and I can do it as XML, whatever you want, just by changing it, because EMF supports it in the end. And another thing you usually have when you have an API, it evolves over time. So it's barely that you have one project, especially long-running projects, where your API stays the same. So and if you want to produce this as a give your customer stability, you usually have some kind of backward compatibility inside it, and whoever does it knows it's kind of hell to keep all these things in line. Docker makes it easier. You can put it in Docker containers, leave the old versions running, but you have to take care of all this stuff. And EMF gives you a possibility to handle this stuff. For example, you would not have no need to really put it in different VMs. You can let the same code run in the same VM in different versions. So this is a small example right here. I have another evolution, a step of evolution here. Switch to step 3. So in this case, the step 3 takes a second. So you see, he realized something has changed, and he's deploying in the background, and so on and so forth. In our evolution, the API model has changed. Before, I only had an attribute which was named description. Now I give the description as a translation object. So some vital part has changed, so nothing is added. It's something is changed which basically breaks my API, which breaks my model. The thing is, I have my transformation here, which now says, now as it goes over, it looks for the DE, and then does the transformation for the translation object in this case. And the other thing I did, I left my old bundle running inside with the old model. So when we look inside here, we should see somewhere gecko, I don't see it, but it must be there somewhere. Gecko demo model, product service, 48. It is the runtime, and I need the modeled projects. API model, whatever, it should be here. We will see. First of all, I say my first object, and I want it in version 2. So we should change it from YAML to XML. Might make things easier to JSON. So first, and this is the plain version. Here we take version 2. So this is the second version. The name is now an attribute, and the description is a complex object. And we should be able to see version 1 still in place. No, exactly we don't. Give me a second. API model version 1. Local, is this version around and available? okay, here we are. It might be possible that I need to reload here so he knows about it, because if you change the version underneath, Is it possible that BND doesn't like it when you replace something like this on the fly? Give it another try. So, new round. Ah, there we are, the old version. So what we have here is two versions of our classes, and behind compiled versions of the classes. So the class loader is really managing to have the same class with the same name, the same namespace, in different versions. Two transformation rules which do the thing. So it's giving you the opportunity, for example, you have a new evolution as a step for the evolution of your API. You can leave your old stuff in place, and if you take care, you can simply leave the old version in, deploy the new version, and everything can work side by side without doing anything. So this is something, also I don't know any framework which is able to do something like this except OSGi together with EMF. So yeah, this is what basically what's the gist of all the stuff we are doing. There's a little bit, a few more things in it, but I won't bore you too much. We have a few things also in the pipeline. The one thing is the Gecko REST and Gecko RSR should be ready as soon as possible. We also have a Lucene implementation where we can use your EMF objects to build an index out of it. We will at some point in the future make public as well. When you are interested in it, Gecko.io itself is registered but not available. We have a GitLab page where all our projects are at. It's called gitlab.com/gecko.io. We also have repositories where you can find all the stuff to use it if you'd like, and also a Nexus with the Maven capable dependencies for it. So, questions before I bore you anymore?
Or maybe you thought about having a break now, so if you have any questions coming up soon, you can also ask Jürgen directly.
Yeah.
And for that I would like to thank him, and also will, of course, stay inside of the tradition of getting a wine. Also the local one, of course. Maybe
so then I can try something local, thanks.
Yeah, so, yeah. Thanks for being here and giving the talk, and also presenting Gecko.io, which is maybe quite an interesting alternative to OnRoute.
Yeah, when it has a website.
We're working on the documentation. So.